ITI's monthly Showcase webinar series. My name is Christina Lanham, and I'm the Manager of e-learning here at ITI, and I'm filling in for Jonah Hobson this month. Today's webinar is going to be on jacking and rolling best practices, and your presenters are going to be ITI's Technical Director, Mike Parnell, and our Project Manager, Jonathan Parnell. Just for those who may be new with us, to let you know who we are, ITI is a crane and rigging training provider. We've trained around the globe and through a variety of industries, as you can see with the numerous different customers that we have. We touch on manufacturing, power generation, wind energy, just an entire plethora of industries that utilize crane and rigging. And here's just kind of a look at the team that we bring to the table. We have trainers in the U.S., Canada, and in Brazil. And so we've got 14 instructors right now performing training around the globe. And at this point, if you guys have questions as you're going through the webinar, just be sure to click over into the chat section and write your questions down, and we'll get those answered at the end of the session. And I'm going to go ahead and pass this over to Mike and Jonathan.
Thanks, Christina. It was really nice to have everybody with us today. We hope that you've enjoyed the previous Showcase webinars, and this is a subject we've been teaching and working on and doing project work for a number of clients since the 80s. And so it's you go back to the Egyptian times, and people have been moving a lot of stuff horizontally for a lot of years and centuries. So, but we want to kind of focus on where we're at using current equipment, some best practices, avoiding certain risks and hazards, and making sure that we cover blocking and cribbing, especially because eventually we've got to land the load or get it suitably supported to be able to transfer the load. So I'm going to turn it over to Jonathan, and then we'll be working back and forth to help bring the information to you.
Well, thanks for that introduction, Christina and Mike, and we thank everybody for signing on today. And like Mike was talking about, we have just kind of a list of things that we're going to be talking about, the components of both jacks and rollers, some inspection criteria that we can go through, and where to point you in the right direction for that sort of thing, as well as using different rollers in different configurations and load share, and finally some different calculations on crib piles and inclined planes.
Speaking of the crib piles and some of the load share, make sure that you get your calculators out. You may have them on your smartphones or at your desk or wherever you're at, but we'll need those as we go along, so make sure you get a calculator handy for you. So,
well, moving into our first topic here, we just want to identify a couple of jacks, and some of you in your inventories have mechanical jacks, and these kind of take into account mechanical advantage of a lever device, and we'll kind of show you the different components of those. And some of you might have hydraulic jacks, and this is one example of a hydraulic jack here. And what we're not going to talk about today are any airbags that can lift devices. They usually take an external air source and are kind of unwieldy at times, just like this pen is. And so we'll get going on to the next slide and discuss some of the components. Some of the pieces that I want to highlight here are really the load points. This is where we're gonna attach the load or attach the jack to the load. And here we have a single acting hydraulic jack, a ratchet jack, a self-contained hydraulic jack. Starting over here on the left, the single acting hydraulic jack is usually connected to a hydraulic source of some sort, and then jacked either by lever or by machine. The load point here is really the only point to attach the load to. And this can be typically used in a vertical position, and usually lifts the load vertically. Next over here at the ratchet jack or mechanical jack, we have actually two load points, and it's funny, they list the top point, the top load point as the main load point and the toe down here as the integral auxiliary load point. Typically we use this auxiliary load point because the loads typically that we lift are so low to the ground, but it's just an interesting note that they say that it's the auxiliary. Lever can be inserted in two different orientations here, just based on your reach. And a good thing to note about jacks, at least these ratchet jacks, is that they can be used both vertically and horizontally. The ASME B30.1 allows us to use these jacks both vertically and horizontally. The last one here I wanted to talk about is a self-contained hydraulic jack. You saw in the previous image here we had a primary load point and then a secondary auxiliary load point. And with this drawing here, just another different type of model. We have a main load point there with a load cap, and these are generally used in the vertical direction based on the manufacturer's recommendation.
And they're quite often they're a double-acting jack, or can be a double-acting jack, so that you can lever up and then lever down based on the model type and design, so that you can, instead of, as Figure 1 shows, there's a single acting jack, it would be the pressure of the load, and you back or crack the hydraulic hose open at a coupler at a pressure valve to release. And so it's a bit of a free fall, you might say, to lower. So depending on what you're lifting, you want to select the right jack for the right job.
Moving into jack components, really the connecting piece between the jack itself and the lever arm or the handle is really the most important piece. We show this image here to describe the relationship between the size of jack that we're listing, as well as the length of bar that we recommend or that the manufacturer recommends for use. A lot of times the jacks will come with a specific bar to use, and notice here that we have two very similar sized jacks. They're actually both 5-ton capacity, but in one case the manufacturer has decided to use a bar that's slightly shorter than the one next to it. And this is really important when it comes to making the mechanical advantage work for you and selecting the right jack for the right job.
Also, it helps to prevent overload of the bar, so that we have a limit to the bar length that we can use. So one of those was 30-inch and the other one was 36-inch. But they're both 5-ton jacks, but based on the mechanical advantage and the ratchet and pull system and track system, different manufacturers have prescribed different handle lengths.
That information can be found most of the time either stamped on the jack itself. So for instance, it might be kind of hard to see, but here we have a 30-inch jack handle call out, and that's stamped right on the jack itself. Whereas other companies will write in the jack handle length on the manufacturer's label there. So a couple of different examples, and really getting that jack handle length correct is important. So long as it may not even be the handle that the jack originally came with, but if it can withstand the load and it's the right length, then you should be okay. So let's talk about moving into the industrial rollers portion. We want to introduce these just as two different types, and the first type here is the industrial roller system. Kind of looks like a tank with a turret, and kind of the exploded version here has a swivel top and steel rollers underneath with connecting links. This is all captured inside a housing, and these roll around in many different directions. They can be locked to prevent swiveling underneath the load, and can also freewheel. The way we size these is if they're typically sold in sets of 4, and so the set of 4 here is typically listed as get my pen working. Typically listed at an overall capacity for the set. So for instance, 4 at 40 tons, where each is at 10 tons in this example, or a quarter of the entire set capacity. The other type of rolling system we have here is a 3-point wheel system, and there's a lot of manufacturers that make these. They typically come in synthetic rollers, or they come in a steel roller design. We've got two separate little pups here. These are called pups, and they typically hold the load in a triangular fashion, which I'll show a little bit later. The alignment bar that is set up between them slides into a slot underneath the pups themselves, and then there's a steering handle that has its own set of pups and a swivel head. Typically, the swivel head doesn't lock; it has to rotate freely, and the entire system is rotated and maneuvered by a person. These are typically sold in sets of 3, and the interesting case here is that the steering handle set, say if we had a 25-ton set, the steering handle would accommodate 50% of that capacity, or in this case, 12.5 tons. The other two, the two pups, take up 25% of the overall capacity, or 6.25 tons each in this example. So let's introduce, we'll take a look and see a couple of examples here that we have. This is the Hillman roller. They're a manufacturer that makes these rollers as well as others. This is just one type that they make. They can be used in this configuration or vertically on top of a load to ride on rails. Again, they have a turret swivel lock or release, and you can see the ball bearings embedded inside here that allow that to happen.
Down below there, the steel rollers, they also certainly make synthetic rollers, high UHMW or high density synthetic material, and to help for non-marring. Sometimes the wheels are larger depending on the frame of the roller system. So check with the manufacturer. Hillman's are manufactured in the northeast of the U.S., and Heavy Haul is another manufacturer. There's a number of really good providers. These folks have been around for decades and have really gone to school on a host of different roller types, so it's worth taking a look at their websites to investigate what type rollers they have. Sometimes we'll be able to put rollers upside down and roll a beam on top of them if for bridge installation and other applications. So depending on what the needs are, and some have a hinge top, swivel top, and I think even on the next slide, let's go there just for a minute, there's a style that is a tilt type, so that can be used to go up and down inclines. In this particular case, this is a Heavy Haul design, and that entry and exit incline on the side plates there permit for up to 26% grade. So the incline can be pretty aggressive, and there's just a single set of wheels in there, and they stay parallel to the load, but as the incline changes underneath, the single axle accommodates that transition point on the brake in to go up the incline and the brake over at the top of the incline. So it's really choosing the right roller for the right job.
One note back here at the turret style, the recommendation from the manufacturer is that these can be used on inclines as well, just so long as they're attached to the load itself. However you can accomplish that. Moving into the other type of roller system, this is just an example. We have two of these systems here at our facility, a 3-point rolling system. Not pictured here is the actual crossbar that would accommodate the joining of the pups, both for this large 25-ton set as well as this 10-ton set here. You have a bar that goes between them and keeps them aligned and able to traverse corners, as well as if any unloading occurs, they can stay at least parallel until you get loading back to the pup. One note about these 3-point rolling systems is they are for flat surfaces only, not recommended for inclined surfaces, just due to that transition point tends to mar up the rollers themselves, and then not really used for the loading type on the bolts themselves and the axles that hold the rollers in there. So just a few notes on industrial rollers and how to use them. Typically, when we haul loads, we want our hands to be face down when we're or our palms to be face down when we're steering the load, and we typically don't want to use the steering handle or the steering person to push or pull the load. We want to allow other people or equipment to propel the load itself. And Mike, do you have anything?
Yeah, what can happen on this, the safety aspects for almost any handles used for rollers, and the concept here is palm down. And the reason is, if you're rolling along, and if for whatever reason we haven't cleaned off our rolling surface very well, and we hit some grit or gravel, and it actually freezes or stops let's say this, in this case, the picture of the steering unit, if the momentum of the load can go forward and slide over the top of that roller, and then slam, slam the handle down, and if our hands are palm up, it can take our hands down to the ground with us go with the handle. So it can be pretty much injurious to the steering person, and we want to make sure that we're not we're reducing risk wherever we can, and let that handle get knocked out of our hands if necessary. You can't stop a load that's 4,000, 820 ton, whatever the load weight is, and if the momentum is there, it don't have to go fast, but simply slide over the top of that roller, and it's heading for that handle. It's going to drive it to the ground in a heartbeat. So you want to make sure that we keep some body space back as we're walking. Just anticipate some issues that can occur, but in all cases, first thing is to clean the runway off, and that will help minimize the risk and lower the risk to that.
Those are great safety notes. One of the last roller component type is sort of an old school system and model. We have the pipe or the round stock, and these any type of round timbers or steel pipes that we use to roll along a load that has a base skid system.
Notice this one has two main beams, and then it actually is ski-tipped a little bit on the ends. We have loads like this, and we use pipes at all three of our training centers in Woodland, Washington, and Memphis, Tennessee, and also in Edmonton, Alberta. And the pipes are laid down. These are 4-inch Schedule 60 pipes, and they're laid according to the travel path, and so they need to be parallel when we're running straight away. And then when we need to turn, we're going to put a cone or create a visual focus point out there, and so we'll turn those pipes prior to placing them underneath the load, like the spokes on a bicycle wheel. So, and then we push or pull that load across, and as that hits that angled pipe, the load will turn, and we can make a 90-degree, or even if we have to make a large sweeping 180, it can be done. It can be done with round stock pipes, or even round wood posts, as Jonathan said, that are high capacity, or we use ash, and they're more than fence posts. They'll they need to be a super hardwood if they're wood selected, and such that they'll stand up to the work activity. So, but having some pipes around, it's an old method of moving loads, but it's still very suitable and very handy. If you don't have a set of rollers on a job site, you need to move something quickly. Take a look and identify the size and diameter and wall thickness of pipe that would be most suitable for the load weight, and just make sure that we constantly address ourselves to the center of gravity, and that is making sure that we're always attending to the ensuring that we've got rollers on the front and the back side of that CG. If you only use 3 rollers, you're already going to be in trouble. So a minimum of 4, typically 5 would be good. But we always have to have we don't want to run the rollers out the back end and then have nothing between the center of gravity and the back end of the load, and because we're going to crater that load down and it's going to set back down on the ground, we're going to start jacking all over again. So it's really important to make sure that we straddle that CG and continually support that load on each side of the center of gravity.
Great points about the rollers there. When we talk about jacking, a lot of things one thing that comes to mind specifically is blocking material, and either using jacks on blocks or using jacks to lift a load and then to block underneath the load as you lift it. We have some different information here for the different types of blocking material you may find. Doug fir, white oak, and eckie. Eckie is a very dense wood, and to just highlight some of these parameters here, Janka hardness test. Of all things, they actually fire a ball bearing at these different pieces of wood, and they figure out how much force it'll take to push behind that ball bearing to get it embedded half the diameter of that ball bearing. And you can see, I mean, Janka hardness for the eckie wood is much higher. I mean, twice as much as white oak and Doug fir. So it just kind of gives you a perspective of how hard and how dense this wood actually is. Elastic modulus is the overall strength of the wood, and modulus rupture is how the wood is loaded parallel to the grain pattern. And so if you have a choice to use, I mean, eckie is a little more spendy, but it'll last you quite a while. And Doug fir and white oak are typically used. We've got those in our yard. And if you have any questions or want to find a little bit more information, the source down here, wooddatabase.com, is a useful place to go to find this information. Moving on next to how to inspect our gear. Just a minor note here, we're just going to talk briefly about this, is using ISME B30.1 as our go-to document for the inspection criteria and rejection criteria for these jacks and rollers.
I had the privilege of serving as the chair for this committee for a number of years, and we expanded it from jacks to, it has now mechanical jacks, hydraulic jacks, airlifting bags, air casters. It has gantry systems, and it's introducing now also strand jacks is the next target subject to go in here. And in each of those chapters, particularly to the equipment, there are discussions about testing, if necessary, design factor as applicable, then operating environmental conditions and issues, inspection, removal criteria, and operating practices. So each chapter's got a great listing out provided by a consensus group within the industry. And if you don't have this and you are using jacks and rollers to help move loads, great thing to get. I know you can get it at asme.org or the ITI bookstore, but in either case, it's good to pick up the standard and along with the manufacturer-specific recommendations or requirements or guidelines to help manage the equipment that you have in your inventory and or the equipment that you rent. We didn't list out a whole gob of the inspection criteria here. I think the main things that you want to really look for is, cracks, deformation, broken components, lack of hingeability, certainly on the hydraulic side, leaks, hose condition, valve condition, and so on. So, and certainly missing or legible identification, but within the document, it's got the full rollout of all the inspection criteria, and we strongly suggest that you get a copy and then use that during your activities on a daily and annual basis.
Moving into our next agenda item, one thing that's actually listed in the B30.1 is this comment about using a friction surface or a friction material to place between the equipment and the load itself. And what this does is it's really helpful to use this wood or compressive material to place between the wood and the load, or the jack and the load. Specifically, these load points here where they're going to come in contact with the load itself. What this does is the wood or compressive material actually fills the gaps and sort of equalizes the load on the load point to allow that load point to first of all stay engaged to the load, and second of all to use the entire load point for lifting.
For some of you that have been on previous webinars with us, you know that we've had a number of programs talking about coefficient of friction. The average for steel to steel is about 10%, and the average for steel to wood is about 30%. So by slipping a little piece of plywood or high-strength material in here, we create a better friction face-to-face contact point, and it helps ensure a better engagement or long-term engagement while we have the equipment in use. And the challenge here is constantly when we're going to jack, the first thing that's going to happen is that the load to jack interface contact point will not be perfectly level. And we're generally going to be either potentially putting some toe load to it or some slight side load to it, because we have to move the load, and these jacks are built to do that with the foot base length and width to permit that, and within allowables, which we'll get into in just a second. But we sure want to make sure to stick that jack and make sure the contact surface doesn't move while we're within that operating range or working range.
Moving next into placement and use of jacks. We talked before about the solid and level surface the jack needs to be on. It can be used sideways, but this indeed is one of the most important pieces. Having a level surface to use the jacks. The next piece here is stay within the rated capacity, and a way to do that, and we'll calculate this in just a moment. But whatever we decide is our loading on the jack itself, we need to make sure that the rated capacity is greater than that load. We'll also have to be aware of cross-corner loading. We'll explain a little what that means a little bit later. Jacks typically come in sets of 2 when you're in use, and either using them 2 on a side or 2 on an end.
One thing very important to us is to ensure that this use 2 on the side, 2 on the end, and I want to make sure that we're all on the same page here. If you take a typical base load, we'll just put in a few of these. We'll put we'll say 4 jacks, and that is really not it's a terrible idea. And the reason is we may end up with 50% load cross corner to these 2, 0% load to these 2, and we get the load unstable. And what they call, what we'll call it or term it is that the load can helicopter down meaning that they can all fall sideways with the instability of the load. And all 4 jacks can literally all fall in a counterclockwise position or clockwise position and literally take the load back to the ground in a heartbeat. So really the idea is to just use those 2 on the end or 2 on the side at a time and commit ourselves to only work slowly, efficiently, effectively, 2 on the end, 2 on the side, and we'll work the load up by installing blocking and cribbing as we go. Now, and the synchronization is really important. You know, one guy can get too far and too fast, and it's really, especially when you use mechanical jacks particularly, but certainly hydraulic. But if you think about the process, you have to call out a cadence, up 1, up 2, up 3, up 4, and each person handling that jack is in cadence with the brother next to him. So we're trying to equalize load as best we can.
All right, those are great practices to use when we're using jacks on both sides of the load or one side of the load. Talking about stability, also when we're using, we talked about using jacks to provide stability and what stability looks like for jacks. We want to talk about rollers too, and specifically the stability triangle, and that's what we're really trying to achieve with our 3-point system here. This depiction is meant to show the load that as it sits, possibly over the roller system, maybe a larger load here with our center gravity in the center, and we really want to capture that center gravity as best we can with as much distance as possible between the center gravity and the sides of our stability triangle. That'll provide us the most stable platform to move the load in.
Jonathan, we just got a question, and I think we'll break in here to the program with that question. We'll go back to this one particular frame here, but I think that the question's really well placed, and the question is, can you use jacks of different capacity? And I would suggest that we end up with the need to have, if this is these really should be each 10-ton jacks, let's say, if that's the size needed for that particular load, and of the same manufacturer. You can really get in a bind with one using, let's say we'll use a 10-ton and a 20-ton. Well, they're going to have a different rack, the gear teeth, the span, the stroke height per stroke is going to change or be different between the two. Be really, really very dangerous or ineffective. In that case, you'd almost be better off, really, if you can stand it. So the answer to the question, no, you want them paired. You want them same capacity, same manufacturer because of rack and travel, stroke length, stroke height. I'm going to take out this little jack right here for a second, and we're just going to go to the end here, and we're just going to install one jack. We might use a 20-ton jack right here as a single. You'd be better off using single jack at the midsection of that end if you didn't have two matched pairs with enough capacity to handle that end of the load. So using different jacks of manufacturers and different capacities, fast way to get in trouble. Using hydraulic jacks, we're going to end up with pressure issues, height. You can feel it in your hand as you're jacking some on hydraulic jacks, but if you have different hydraulic jacks, not a good idea if they're hand-driven, so they need to be matched. And also, you have height changes in the jack itself by either the main load point or the auxiliary load point. The the available stroke height for a hydraulic jack from 10 ton to 20 ton will be different. So, you know, there are issues related to that. If they are plumbed together on a common console, and we have two of those, so let's put in another one. Sorry about that. So we put in two of those side by side, and they're plumbed together into a common console. Then we can run them off the common console hydraulically and introduce the same amount of pressure to both. So there are methods to tie these together, but let me assure you that getting different puppies out of different litters, there's some really risks involved in that. We've never permitted on our sites to use different manufacturers side by side or different capacities side by side. That's an excellent question. I think we answered most of this, Jonathan. Is that right?
Yeah, that's right. Let's move on to the next piece of information here, and keep bringing your questions. We don't mind stopping for a quick question if it's really pertinent and we want to answer everything we can for you. And talking about placement and uses of jacks, we want to talk about the load, and really another point from B30.1 is that the jack, or the load grade itself should not exceed 4%, and we have a couple ways of determining that, and really it's determined by the distance from one end of the load through to the other, in multiples of 100 or 50. Those are the easiest to do. But say we had a height difference here of A, and really the equation that we want to solve for here is A over B, just like it says right down below, times 100%. Should not be more than 4%. And what we mean by that, just as an example, if we have one good rule of thumb is if we can measure out 100 inches from one point of our load to another, and we can measure out 4 inches in vertical height change, we've reached our 4% grade here. And that's a good time to stop and place blocking material underneath that load, and move to the other side to level it out and get it up where you want it. Put it on rollers or some other system underneath it.
So why don't you, on your drawing there, help demonstrate too that you can go 4% below in a different color there. And so we have actually a full stroke. We can go 8% change as we're jacking one in. So we might be 4% down. And let's see, we'll put it down here so that we can, the load can be on this incline and go up to 0 and go up to 4% grade above. So you actually have quite a jacking range when you consider we're trying to walk a load on the end all the way. So on the picture that's there, we're already down. We'll block this in, and we'll come across with our jacks. And so we're already at the -4. We'll go up to 0 and go up another 4, and then we'll have this new incline here, right? So it sounds fairly restrictive, but when you actually start moving a load and getting it built up on blocking, you have this. You have an entire range of the -4, 0, and +4, and actually that's quite a bit. And you chase it up with blocking to ensure, in case you have a for some reason you have a jack failure or something else that goes crazy on you. Chase the jacks with blocking so it may be raising 1 inch, 2, 3, 4 inches. You're continuing to shim or put blocking material in there temporary. pull out the 3.5 inch, put in 5 inch or 5.5 inch as it continues to walk up.
Great points there. Moving over to the rollers and talking about the placement and usage of rollers, and really the use in this case is how to get it from point A to point B, and what are some of the considerations we want to make in doing that.
So we put this drawing together just quickly that this load has to travel and get to this landing point right here, and this is part of, we want to make sure and prepare a travel path properly, and that means cleaning the floor off and taking all the debris out of the way, and also the methodology. So as we want to take this approach here, I'm going to highlight this so that it is, I probably start this load up a little bit. If I can renegotiate this load and take it up just a little bit on the, we'll call it to the north side, and reposition that, jockey back and forth before I make my entrance. So notice that I'm hugging that north demarcation line or wall there, and then I'm going to have it flow through and make that hard turn and sweep all the way going east. And I may stop here because I've got to get to my landing point right over here, and I can't hardly make that turn. So what I'll do is I'll back that load up to here and then renegotiate that and make a tighter turn. I'm sorry, more sweeping turn there, and it'll actually overshoot, the front will overshoot my landing and come back into some center point there. So where do I have to clean off? Well, where my rollers are going to be, and my rollers are going to be in this arc here, and so notice that I'm shading. I need to clean that runway or clean the travel area off, and those aren't always hard areas. So they may be floor marks or floor travel paths, but anywhere that those rollers are going to be traveling, all that area in between may exceed your, a pre-planned roller path, but that area needs to be cleaned because we don't want to have to stop and then re-clean something while we're in motion. So prepare the job, prepare the task. One, identify how we want to move the load, and number two, okay, based on that, what's my shadow that I could possibly run my rollers into that I need to get a debris-free floor so that I don't have any interruptions, or that it doesn't grab my rollers and stop it, turn it, twist it, or cause uncontrolled movement. So just as a point of information, but pre-cleaning the floor is really the secret for a good, efficient rolling project.
Talking again about rollers, and really we want to highlight this difference between using 3 and 4 rollers. 4 rollers are absolutely acceptable. They come in sets of 4 anyways. But one caution we want to point out is that undulations in the floor can cause loss of 1 or 2 rollers. And let me highlight what this means down here. We can have maybe a low portion, maybe a depression of some sort in our flooring, and if that's the case in this roller setup here, we could actually end up leaving the load altogether with this roller, and in turn we may the load may drop to this side, or it may teeter-totter on both of these loads here, or both of these rollers here. And we may have even a disengagement of this back roller here to slow down and even stop while the load is still rolling. And so in some cases, or a lot of cases, a manufacturer of industrial rollers will recommend selecting rollers of a higher capacity, up to 25 or even 50% over what you think the roller is actually going to use. And it's just for this very reason, this cross corner loading that could occur because of these different floor levelness tolerances that we see.
And I noticed that some manufacturers are coming up with a compression pad to try to maintain at least contact with the roller to the load, and it may be a compressible, like a thick rubber pad that's very high density. that springs up and down slightly as we get undulations in the floor. This is a very common problem, and as a rule, typically, even with a four roller set, we'll only use 3 rollers within capacity and reposition them, as you'll see in the next couple of drawings and downstream in the presentation. But 4 rollers really are a nightmare sometimes. So you really have to weigh and decide what's my best opportunity here for maintaining control. Let's take a look at the next one. Generally 4 rollers steering on one end. This is, so if we have compression material and we have a really good flat floor, we truss the system. So that's how this is set up. And each of these, the 4 corner rollers, we've got stability for the load. That's always a big issue, is how far are we from the center of gravity to the wall, you might say, created by the rollers. And so we're going to want to, let's say we're going to make a left-hand turn here. What you probably want to designate, you're going to have 2 people out here, 1 on each handle, and we'll just call this handle A or roller A and roller B. And you want to designate one of them as sort of the primary steering roller, and that person then will kind of predetermine he's going to make that turn with that roller. Now they're going to be the arc's certainly going to be a little different, and so trying to maintain parallel the best you can. And if A is the primary, meaning that my job on B is to track with that roller to the best of my ability to the least amount of resistance. And notice that arc is larger, so some negotiation with that roller with the handle is really important. But you can only have 1 lead dog, and basically you assign that maybe to the inside roller, to that person, and as he turns that roller, he makes slow, steady turns and holds that in position. My job on B is to track with him and make that arc work. And of course the tail pups back here on the back end are locked straight, and they'll try to make that turn as they get there to accommodate that counterclockwise, let's say in this case counterclockwise move. But if both of them are primary, they'll argue. You'll end up with one turning faster than the other. So you just have to set an order, a hierarchy, and assign one as primary, one secondary, and the secondary keeps up with the primary. One thing to kind of keep in mind with using rollers like this is, you know, and the method I described is like slalom skiing for snow skiing, or using 2 skis and keeping the skis parallel at all times as you're trying to maneuver down through the snow, and avoid snow plowing. So that is where the skates or rollers are towed in and they're fighting each other, or towed out, they're fighting each other. They're causing complete resistance to forward movement. So avoid snow plowing, which really the instruction is to keep them parallel as best you can as you're moving through a low travel path.
So moving into those are 4-point systems. I want to talk about 3-point systems. Even with a 4-roller set, you can use one as a 3-point system, and we typically recommend single steering when possible. Sometimes it's just not possible. I know we had a large structure we had to move here, and we used 4 and even had 5 guys underneath and moving and maneuvering a load. So this 3-roller concept here is like we said before, it's common to impose 50% of the load on the steering roller. And in general, the concept here is like a 3-legged milking stool, and there really is no there's really no opportunity for the load to come off of the rollers themselves and sort of disengage from those rollers. Maintains constant load.
So with an undulation in the floor, 1/16 inch, little belly or a little hump, will maintain constant loading all the time, though it's not perfectly flat. but a 3-point system will always be your best friend to manipulate or work these rollers and loads through a load path.
Moving now, generally, if we're talking about steering on one end, you know, it's possible to pass the handle underneath the load, and the other end is going to trail straight on the other end regardless of what the front does. One way to produce a little bit tighter turns is using the school bus setup. If you notice back here in this image, we have some distance here between the center of gravity and the back axle location. And using a school bus method, we can actually move the point of application for our rollers a little bit closer to the center of gravity. We still have a really good stability triangle here with our rollers, but this allows us to not use the entire load's length, but instead, if we have a really tight corner that we want to try and get around here, we can actually use this roller as our pivot location and then start to turn the load that way.
So a shorter wheelbase accommodates tighter turns, and so we move that back axle up and the two pups get closer, but we still have to certainly maintain stability. This will certainly cause you to stop and recalculate the load imposed on those two rear rollers, because they're now, in this case, they're probably looking at load there versus load here. We may have 80% of the load on the two pups on the back end, 20% on the steering. So the closer they get, the more they accept of the load's total weight. And so you just have to make sure, are we still in rated capacity? That is always a question. Three things in rigging. One is, what's the load weight? Where's the center of gravity? And what's my rigging method? That could be above or below the load based on lifting with slings or jacking and rolling it. But always attending to, where's my pick points, my bearing points, my support points in relationship to the CG. And then double check the rated capacity and make sure we've got enough horsepower in the support equipment to handle that weight.
Talking about rated capacity, we've provided here a way to calculate load share for a 2-jack system when trying to lift a load using jacks. And we've got, just to orient you, we've got run 1 here and run 2. Those are in relation to the jack to the center of gravity, and then the end of the load, or the tipping axis, to the center of gravity on the opposite side. Ultimately, we want to know just the load share of one of our jacks, and we can use this set of equations here to help us figure that out. I want to take you real quick through an example, and we'll take a look at some distances here. So down below, we've got say 2.5 feet and 7.5 feet. That is 2.5 feet from jack 1 to the center of gravity, and 7.5 feet from the center of gravity to our tipping axis right there. The weight of the load itself is going to be 18,000 pounds. Oops, hashtag sign there. And so going through our set of equations, we've got run 1 plus run 2 equals the total span. So that's the span between jack 1 and our tipping axis. And if we go 2.5 feet plus 7.5 feet gives us a total span of 10 feet. Now, the interesting thing about this is that we have an inverse relationship when it comes to loading. That's one of the central ideas of load share. And really, it's the distance between the center of gravity and the tipping point is going to be the relationship, or the ratio of load weight, or the proportion of load weight on the jack itself. And so if we take 7.5 divided by 10, we get 0.75, and that can really be said as 75%, or 3/4 of the entire load is on both of these jacks right here. If we want to find loading to just this one jack, we can figure that out by taking 0.75 times 18,000 divided by 2, and this 2 really represents that we have 2 jacks in the entire system. And this comes out to be 6,750 pounds to that jack right there. So if we have a 5-ton jack, we've got enough to lift at least this share of load here, another 5-ton jack on the other side, and we're good for that side. Next part here is looking at positioning of jacks or rollers in relation to the center of gravity and how it's important.
What we've done here is this came from a workshop that we used in our Master Rigger course, and the idea here is load share and stability. These are 2 questions, and we're looking down on the top of a load, and there's 3 different systems that we're potentially could use. This got a big flat bottom on it, fairly structurally sound, and so the question is, could I use roller set C, and I'll just highlight these in color in yellow. Could I use that roller set around the load? And then let me highlight A. There's A and A and A in the corner, and then highlight B, set B. And let me highlight those. Sorry, got that one out of alignment there. I'll get that in. And that's blue, and this is blue, and that's one that's green. So let's take a look then. If I opt for C, take a look. I'm just going to draw a line from roller C to roller C and roller C here if this was a proposed setup. And notice how close that center of gravity is to each wall created by that, plus we have substantial loading here. I'll just put this in blue. We may have 80 to 85% of the total load on one roller as close as it is to the center of gravity. This may be in the 3 to 5% range out here, and down here is going to be the balance 10 to 15% or so on this roller. So we have a really disproportionate loaded system here, and stability is really a substantial issue for us. We want to be very, say, well, C doesn't look too good to us, so let's take that out of the swim here, and we're going to go into A, and let's just draw a line from A to these guys, this guy, and come across, and we're back into substantial misloading, you might say, or some super high overloading. These 2 guys right here are carrying substantial portion of the load, and the little one out to the outside is kind of on vacation. So we don't really have much help out there, and the stability issue is huge. That center of gravity to that tipping axis right there created by those 2 rollers can really lead to a very unstable condition. So it's poorly loaded, and stability is a big problem with this using that A system there. So let's take a look at B, and we'll draw some lines here, there, and back. Now we've got a pretty good system here that the center of gravity to each wall is reasonably equal, and those 3, we're just about a third, and third loading for those 3 rollers. So we're splitting the load weight out to thirds. We've maximized the distance for stability the best we can based on the load surface and structure and available footprint. So it may look a little crazy, but the idea is think about weight, think about center of gravity, think about stability, because the rollers are below the CG, and if we get that wall too close to the center of gravity, we have a tipping issue. And a number of loads have actually tipped over because of momentum turning, and all of a sudden the load goes sideways. Think about it like this, and so when you set up rollers, you want to get the idea as if you just drop a rock in a pond, and that little rock right there is the center of gravity. We're going to drop that right in the pond, and we're just going to create rings. And the little pool rings that come out once you drop that in, and where on that ring series can I put my rollers? And so we'll highlight this. You know, that B falls right in that ring series so that we're maintaining our best optimum for share of load and for stability. So if that be the case, since we would choose maybe 3 points to roll this load on, just think about working out from the center of gravity outward in uniform distances, and then try to, or attempt to, ensure that we have equidistant or equal spacing one to the other That's, you know, it sounds like, well, that's the perfect world. Well, you know, sometimes you start there and say, if that's doable, great. If that's not doable, what's plan B? And let's see, and go from there. So that's the concept and thought, and we wanted to bring that to your attention.
So moving into after we use our rollers or pups and swivel heads, we want to park these things, and a useful parking method in this case is we want to orient our pups, our rollers now, towards the center of gravity, and 2 will do, but 4 is great. This will keep the load from rotating and from sliding along at maybe a slight incline, or even being pushed and induce some type of movement. Really, we're just create immobility here. With our swivel system, we're going to turn these rollers, the swivel head, opposite or in different directions than our pup system here. One of the things you want to remember is when we do that, and we want to park this load for a brief time, to remove that handle so we don't have any tripping hazards or any equipment rolling over for crushing.
Or we'll need to, in this case, if we can't reach or don't want to reach underneath the load, we'll barricade it or tape around it and secure it. And also we can make sure that if a large load, we may need to backstay it with a winch, or with a winch from either direction or both directions, or stay it with guy lines, guy wires, etc., or jack and block one end and put it on blocking so that it can't roll anywhere. There was a question that came in, and it was about maintaining parallel lines with your rollers, and you certainly want to do that. Let's just point these all in the same direction here for this load. And yes, you want to maintain that. The pups, there's a tie bar right across here on the back end, and then this is the steering end. And so we can negotiate that, and that can turn, you know, to the left, to the right, etc. Notice that Jonathan put up to park this load, we make the rollers fight each other, and so that it's just physically impossible to move that load north, south, east, west, or any direction in the 360 degrees, because the wheels are pointed against each other, and there's resistance there from movement in any direction. Let's go ahead.
We're going to talk briefly about crib piles, and we talked before about the types of wood that we can use for our crib piles. We recommend using a Lincoln log cabin style configuration when we build our crib piles here, and the reason for that is they interlock, they transfer load directly to the logs underneath it, and then ultimately we want to we recommend creating a flat, fully supported surface. This can be achieved by wood stacks or blocks, steel plates, some type of material that's not going to be compressed or crushed, but can take that compressive force.
So it's all about load spreading on the base layer and creating almost like a crane mat, an outrigger mat for mobile cranes, etc. So we're trying to spread that pounds per square foot over a broad surface, and if we honeycomb the bottom layer, we're missing half the ground. So if we build a solid block layer, it's much more helpful. And in this vertical, if we take a look, the columns really are created there at each point. Each step we've got another 4x4. If you look straight up and down, we've got vertical columns all the way along in that vertical on the broad side and on the narrow side. And there is a lot to think about that. It isn't uncommon that the load spread, as we apply load here, we're really kind of, it does send that loading down to that base in something of an angle. So if we have the load landed up here crosswise on the top, we are getting some help. Not only vertically, yes, all our columns are helping us, but we're getting some of that load spread base at some angle there as it approaches the bottom section. And there, if you take a look at Shapiro and Dewar and some of their writings, it discusses the ability for even a little bit with the more firm ground, we're getting a little bit of outside load to the ground subsurface, depending on its compaction. So the same thing happens really in the wood stack, that it's not all perfectly vertical, but it does head down towards the bottom in a bit of an angular orientation.
I'm going to jump to this one, and we'll come back and provide some calculations. But the previous example spoke a lot about the cribbing underneath of a load, but this one involves the actual use of jacks on a load. And in this case, we want to look at providing the jack base, the base of this jack right here, with an entire column of material underneath it. And notice the profile view and the perspective view here is that we've provided the base of this jack with an entire column of material from which to support it. And so if we look here at some of our wording, crib material is aligned below the jack, and the primary auxiliary load point fully engages the load. And so we don't want to hang off of the crib pile with part of our jack base, just because we ran out of room. We want to build another crib section underneath here to provide enough stability for that base. Make sure it's fully supported. So coming back to another portion here, we wanted to provide a little bit of calculation for the loading that we're going to apply to the ground itself. If we end up loading our jack or our block pile onto some ground, and a lot of times you'll find a ground-bearing pressure allowance for some sites, and we've just provided a scenario here with 1,500 pounds per square foot as our allowance for this ground.
Pretty soft ground, it's pretty fresh construction, and it's pretty light, so we just got to make sure we spread that load out, right?
Yeah, typical values for compaction at construction sites is generally 3,000 PSF. This is kind of what's noted as the standard for compaction results on construction sites. But if we take the share of load and we divide it by the cribbing footprint, so for instance this 2x2 cribbing footprint and the share of load between cribs A and B, we're going to get the pressure imposed on the ground in pounds per square foot. We can then take that value there and divide it by our allowable pounds per square foot, our allowable ground-bearing pressure, and get a percentage of how much of that allowable we're actually using and imposing onto the ground. We could take you through a quick example if we have too much time, but hang with us if you like. We'll just do one side here and talk about the the imposed ground pressure at column C here. And so if we have a tire total load weight of 30,000 pounds, we know that the load share is a function of the inverse relationship between the center of gravity location here and the distance there. It's going to apply to this load, so we're going to take 10 divided by 20. That's going to give us really half of that load. And so of 30,000, we're going to take 15,000 pounds, and then we're going to divide it by the square footage of our pad there, or our crib pile. So we're going to take 16,000 or 16 square feet, and it comes out to 938 pounds per square foot. And what this tells us is that if we have an allowable ground-bearing pressure of 1,500 pounds per square foot, we're going to divide 1,500 PSF. We're going to multiply by 100%, and that'll give us 63% of the actual ground-bearing pressure that we're using or imposing on the allowable. And so just a way to ensure that your loading and your crib piles are large enough to sustain the load at imposed and not go outside the allowable limits of the ground that you're setting your crib piles on. Kind of switching gears here, we want to look at inclined planes. I know this is jacking and rolling webinar, and we're talking about moving loads horizontally. We wanted to provide some information on how to calculate inclined loads or loads to winches or different types of machinery, and just show exactly how much load we're going to be changing from, say, going from a horizontal position to an inclined position. Here we've got formulas for level surface going uphill as well as downhill, and then different variables for coefficients of friction to use if we're using different skid systems or different skidding materials. Right now we're using a load on rollers, so we'll look at 0.05 as our coefficient of friction. If we go take a look at an example here, we can see that we have a winch system pulling a load. We have a load weight here of 18,000 pounds. Our rollers are inclined and going uphill, and so they have a coefficient of friction of 0.05. So taking our uphill equation, we're going to take the coefficient of friction times the load weight, and multiply that by the ratio of the run, that's this run here, and the length, that length there. We're going to add it to the height and the length, that ratio, and then multiply that by the weight, and that will give us the winch line pull. We're actually going to see if we put a dyno right here, a dynamometer. This is the loading we'd actually see on this dynamometer if we were to pull this uphill. So let's take a look and calculate this out, and we'll take a look and input some of our numbers here. Times 18,000 pounds. We're going to multiply by the ratio of 10 over 10.08. Notice we have we knew the run, we knew the height, we found the length by a squared plus b squared equals c squared, the Pythagorean theorem. And excuse my handwriting here, but figuring all this out now, we've got the height here of 1.23 over our length 10.08. Multiply again by the load weight, that'll give us our force. Our force comes out to be 3,051 pounds. The interesting thing about this is that just because we imposed the incline, that tells us that we've actually increased our loading. So say, for instance, if we got this load up to this position here and we kept pulling, we'd actually see a decrease in our line pull. And we know that by taking this level equation, the force is going to be equal to the coefficient of friction times the weight. So if we calculate that out real quick, if we take the coefficient of friction times the weight, we get 900 pounds. And so you can actually see that, just because we increased we pulled the load up an incline, we're going to have a much higher force on this winch line than we would if we were just pulling horizontally across a flat surface. So talking about kind of in conclusion here and thinking about safe practices, safe use, making a plan for all of our horizontal load handling activities. We want to make sure that safety is primary in our minds, as well as efficiency. Making sure that those surfaces are clean and they're level. We're not doing double work in twice the time. Ensuring that we have capacity that kind of goes along with our safety aspect, and capacity of both our rollers and jacks, as well as the blocking material and winch lines that we use to stop the load or pull it up an incline. Planning is kind of paramount. It takes into account efficiency, safety, and making sure we have the right capacity for our loads and our jacks and rollers, as well as the teamwork that goes on trying to ensure that a plan comes together.
Thanks for the presentation today. We have a new HRRC, that's horizontal rigging reference card, for everybody that's attending today. What we want to have you do is contact Jonah at iti.com, and this is a 14-panel card. It is actually the 8th field rigging reference card in our company for load handling activities. A lot of you have the Journeyman Riggers Reference Card, Master Rigger Card, Rigging with the Big Stuff, that handles load items from 10 ton to 1,500 ton and so on. But we have a new card that will be ready in about 30 days. And you saw a lot of the panels that have been developed for this card, and some panels you certainly didn't get to see yet based on the presentation content. But we would love for you to have this card, JONAH at iti.com. Get a hold of Jonah, and we're going to need your mailing address so we can send you the card. And we'd certainly like to get that to you. It should be easily well before Christmas. And it'd be our compliments from ITI and for attending the workshop today and participating with us. So brand new product coming out as a result of this workshop and lots of other work that we've put in before. So let's get a hold of Jonah and send him your contact and mailing or shipping address where you'd like to have the card shipped, and we'll get it right out to you as soon as they come in. Christina, we really thank you very much for helping host this, and we'd like to see if there are any other questions that we can help offer or answer if possible, or get back to the participant as soon as we can. Anything else come in since we've been on the air here? Okay, nothing else right now. Excellent. Jonathan, thank you very much for your leadership and for guiding us through this. We do appreciate everybody participating. We look forward to having you with us on a future webinar, and you'll all get the announcement in the in your emails coming up very soon. So we appreciate everybody being here with us and look forward to having another session. And I think, question, I'm looking across the table, I think we're going to have another session before Christmas. Is that right?
Yes.
I think we have one in November. So, yeah, be looking in your email box. It's there for an announcement about our November program, and we get an invitation to sit in with us. I think we have a guest, maybe have a guest speaker for that one. And one of us, from Samson Ropes, that's right. We'll have Samson Ropes, synthetic rope manufacturer, and fantastic information about pulling lines and large slings made with high-performance rope materials. Jonathan or I or both of us may be hosting that along with the Samson representative. So fantastic having you with us. Thanks, and we'll close out for the day, and we hope everybody has a safe and profitable week. Take care, and we'll talk to you soon.